strong understandings of this. Now, I expected yesterday for you to struggle greatly with this kind of question, but today, I don't expect you to struggle so much. I think we should have done much better today. Okay, so first off, yesterday's lesson really focused on the difference between the staple and the parenthesis. What does the staple mean?
You can equal.
You can equal it, so what kind of circle do you make? Filled in a solid circle. And what does a parenthesis mean? Somebody on this side? What's that? Go ahead.
Not equal to.
Not equal to, and then it would be an open circle. Okay, good. So I start at the point -3, -5. -3, 1, 2, 3, 4, 5. And then all the way up to -1, I do a rate of change of 3. So that's up 3, 1, 2, 3 over 1, 1, 2, 3 over 1. I want it to go to -1, but I need an open circle here, not a closed one. And there's my first part of the graph. How'd I what?
How'd you do that? Like, how do you know that you gotta stop there?
Because this -1 here, that tells you you only go from -3 to -1. This is an interval. It's called interval notation. So it's saying from the interval from -3 to -1, this is, ready? -3 to -1, here's the rule I want you to follow. I want you to follow the rate of change 3. Next one. From -1 to -3, now this time they're both staples, so they're both going to be solid circles or filled in circles. We said starting at the point 0, 0, but we changed that, if you remember, to -1, 0. So I'm going to go to -1, 0, which is right here, and I'm going to do rate of change in -1/2. So I'm going to go down 1 over 2. I go all the way out to 3, so I do it one more time, down 1 over 2. We said they're solid circles, so there is my movement. Okay? Any questions? Preguntas? We're good? Okay, you faked me out on that one. I said, are there any questions? And you went. I was just about to say, but I did not. Okay. Next. From 3 to 6, inclusive, so filled in circles, start where I left off, rate of change of 1. So up 1 over 1, up 1 over 1, up 1 over 1, and that would be 4, 5, 6. And I connect the dot. Okay. Now, what do I go to on the next step? Where do I end up? What's the last x value I hit? There's nowhere near enough hands up. Go ahead. 8. I know I stop at 8 because it says 8 right there. They're both solid circles because they're both staples right here. Rate of change is 0. 7, 8. There we go. Okay? And again, I come back to what we call this, which is a piecewise linear graph. Okay? Any questions at all about how to get this done? Now, I said to you earlier that what I really want to teach you this year is not so much directly math. I think the math comes along for the ride. What I really want to teach you is how to be the best student you can possibly be. Now, the first day that we ever do something, we never do something only one day. The first day you don't do it, you don't understand it. Not an issue, never a problem. But then we go over it, the next day you should understand it. So if you did not get this graph correct, and I'm sensing there are some of you who did not, it's very important that you make it a point over the weekend to go back and study this graph and to make sure you can get the graph correct. If you can't, then watch the video, replay this section to you, and have it remind you. If you need to, replay both days worth of sections. Okay? Any questions? All right. So now we go to a new topic. We spent the last 3 days on piecewise linear functions. Today we talk about quadratics. We talk about how to get the output of a quadratic function, how to determine this thing called the average rate of change, which is a little different than just the rate of change. It's done the same way though. Values in A, B, C in this quadratic equation, and the similarities between h of t and h of x functions. Okay. Oh, we have a second function, a second question on the do it. Given the function y equals 3x minus 5 in the domain, what is the corresponding range? So domain means what? Input or output? Input. So I'm going to input each of the whole numbers between -2 and 3 and see what I get for the output according to this rule. If I plug in a -2, I'm going to get 3 times -2, which is what? -6, minus another 5, which is? -11. Good. God bless. Now I'm going to do -1. What's 3 times negative 1?
Negative 3.
Negative 3. Minus 5? Negative 8. Good. Next, I'm going to plug in a 0. 0 is my favorite. 3 times 0 is? 0. Minus 5? Negative 5. Plug in a 1. 3 times 1 is? 3. Minus 5 is negative 2. And then 3 times 2 is?
6.
Minus 5 is 1. Okay? So that's how we generate the range. Range means the set of all outputs. So I put in all the inputs, and out comes the outputs. Okay. Next up, I need a volunteer. You got it, Lawson.
What am I doing?
Go climb up on the counter. Yep, climb up. Hop up. Nice. All the way, stand. And walk out to here. I will save your life if there's an issue or a problem. Okay, hold this. Put it high up over your head. Now make sure when you drop it, it's going to land on the floor. I want everybody to watch the rubber band ball. And she drops it, and I'm going to ask you what are some observations that you might see. Go ahead. Go ahead. What do you see? It bounced. What else did you see? Yes, energy of motion. Very good. When you hold it up high, what kind of energy is it? Central energy. Good. I want you to watch the relative speed of the ball. Go. What do you notice?
Pretty fast.
When is it pretty fast? When it's dropping. Okay. Is there any time when it's pretty slow? Watch again. Is there any time when it's pretty slow?
When it's dropping again after it bounces.
That is one point in time. There's another point in time.
When she's holding it?
Yeah, when she first drops it, right? Watch. See how when you first drop it, it almost like, and it gets up to speed. Watch it one more time. And it does the same thing when it gets to the top here. See how when it gets to the top, it kind of slows down, reverses, and comes down?
Okay.
All right. So now, that motion of an object is exactly how you and you and you and you judge a pop-up.
The what?
A pop-up
The what?
in softball.
Oh my
A
god.
fly ball.
Oh.
The fly ball gets hit. Isn't that what happens?
Yeah.
The fly ball gets hit. It goes up and up and up, and you sense it slowing down. So when it starts to slow down, what do you know it's going to do? It's going to turn. And then your mind is actually processing all of this really, really fast. As it's going up, you're saying to yourself, like you often take a step or two back, and then you make a judgment, and you say, oh, no, it's starting to slow down. Now I can start to move in a little, and then you make the judgment on that. So the observations that we're looking for, the first observation is that when it first moves, it's slow. The reason it's slow is because you're getting to, it's at its maximum height. Watch the ball as I toss it up from my hand. Bless you. You'll see it starts with initial speed, and then when it gets up to the top, it slows down. Also want you to watch the shape it's going to make. See that moment where it kind of slows down up at the top? Watch it again. Okay? You see that shape like this? See that? Watch it one more time. See that? That's called a parabola. We'll talk a lot about parabolas this year. Much. Yep, parabola. P-A-R-A-B-O-L-A. Next. First moves, very slow. And then it speeds up. Okay? Those are the two big observations I want you to make. Okay, next. There was a video to watch. We told you before we don't get the video up or the buffer. So, there are two different functions. There's h of x and h of t. And the bottom line is that one of them shows the height at any particular point in time. And the other one also shows the height, but it also shows the trajectory of the ball, okay? Now, this is what we want you to be able to do. H of t is not the actual trajectory, it's the parabolic shape of the ball. And we just said, like, if I toss the ball, the one I just tossed from hand to hand, that kind of went like that, right? If you're a great baseball player, who's a great baseball player? Who's the hottest baseball player the hottest hitter in baseball today? And girls, I'm not talking about looks. Who is the hottest hitter in baseball today? Who is it? Derek Jeter's retired. Who is the hottest bat in baseball today? By far, Yoenis Cespedes. No, Yoenis Cespedes on the Mets.
I don't know who that is, and I like the Mets.
Oh, if you don't know who Cespedes is, you haven't watched. Since the day they traded for him, they've gone from 2 behind to 9.5 in front.
Oh, my.
Okay, yeah. Yoenis Cespedes hits 500-foot home runs. So his ball might go like this. Okay? So the shape of the problem might change, how fat it is, how tall it is, etc. But it's still that shape is called a problem. Now, before we start going too nuts on the material, let's get a little bit of an understanding of what's going on. So this shape, this quadratic, always happens when there's a term that says squared. When you see something squared, when that's the highest term, that means we're talking about parabolas. Okay? Evaluate means tell me the value of f of x equals x squared plus 3. So have you seen this f of x notation before? Okay, that means the output is the same thing as y. F of x and y are the same exact thing. The output is x squared plus 3. So x is the input. So if I give an input of 7, what's 7 squared? 49. What's 49 plus 3? 52. Good. Let's try the next one. F of x is negative x squared plus 3. What's that going to work out to be?
Negative 49.
No.
What?
I want the whole answer.
Oh.
Negative 46. Good. Now the important thing to remember here is, what's the difference between the first question and the second question? Obviously it's a what? The negative. The first one you only have to square it. In this one, the question is, do you negate it first or do you square it first? The answer is that you square it first, because that's an exponent. And negation is a multiplication. So you want to square first, then negate. Order of operations. So I square 7, that's 49. Then I negate it, I get negative 49. And then what's negative 49 plus 3?
Negative 46.
Negative 46. Good. Likewise, what's 2x squared plus 3 if x is 7? 1 second. 2x squared plus 3 if x is 7. Go ahead. No. You're on the right track. I think you just made a math mistake, a computational mistake. Square 7, what do we get? 49. Then you got to double it. 98. 98 plus 3 is 101. Good. Okay? All right. So now let's have you figure out what's h of 5 if h of x is x squared plus 4x minus 3. Do it.
So h is 5.
H of 5. X is 5. See, it says here h of x, and then it says h of 5. So that's saying the x becomes 5. Plug a 5 in for all the x's there. And then tell me what it equals.
Okay.
I don't think it's 2. Did you say 2?
42.
Or 40?
To make it.
Is this the way class works? Maya says the answer and you say you're right? Is that how things go? I just to know, because if that's the case, I can make a lot of money doing nothing. So, all right. So let's plug in a 5. What's 5 squared, everybody? Oh, this is a killer. This is an honors class. It's 25. It's not even a Monday morning. And what's 4 times 5? And minus 3. So what's 25 plus 20? Minus 3? 42. Nice. All right, let's do this one. H of 2 if h of x is 2x squared minus 7x plus 4. Okay, figure that out. And by the way, we're not doing just one day of this. We're going to do 2 days of this as well. So if you're not completely perfect on this, we have a lesson just like it on Monday.
Negative 2.
That's Hunter's way of saying, yo, this be my class. You listen to Maya, you listen to me. And even look at his shirt. His shirt even says the same exact thing. He's got a kid that looks like Alfalfa with a cowboy sheriff hats on there saying,
It's from The Walking Dead.
it's from The Walking Dead.
Yeah.
That is the most stupid show.
I hate that.
That show is beyond stupid.
It's not beyond stupid.
Oh, yes, it is. The only thing that's worse than that is
Cheers is a good show.
Cheers is a classic show.
So is Walking Dead.
First off,
That's-
First off, I am slow and miserable. I can outrun those guys. So how did they catch anybody? And then, come on, just give me a really long knife like ISIS would use. And I just gotta spin around in a circle. I'll keep cutting them in half. There's no problem. And then, like, people, it's incredible to me how stupid people can be. Did you ever drive down the road and see, like, someone with an SUV that says, like, Zombie Patrol?
No.
Oh, yeah. You've seen it. I'm like, oh, this person votes. Oh.
I mean, I don't believe in it, but it's a good show.
Truth is, I watched the show once in my life. I woke up at 4 o'clock in the morning. I was on a fishing trip in Pulaski, New York, which is right up on Lake Ontario. And I go fishing with this guy who's in the military. And if you got to be on the water at 7, he wakes up at 3:30. If I got to be on the water at 7, I wake up at 6:45. Okay? So he wakes up at 3:30, and I'm like looking through these eyes, and guess what he's got on TV? The Walking Dead marathon. And I just watched them like they were in a bus. Did you ever see the episode when they were stuck? Yeah. And you watch way too much of this. And I'm looking at it going, Pat, what are you doing? Go back to bed, Pat. This is ridiculous. I can't sleep. Pat, put an infomercial on. Anything but this. All right.
Guy or girl?
My wife's name is Sue. Do you think I'm in a motel with a girl named Pat? There would be major problems in the Lindquist house. I have never cheated on my wife. I don't think I'll ever cheat on my wife. But there is one woman whose beauty blows me away. Absolutely. Shania Twain. I think Shania Twain is so beautiful.
I've heard her.
Has anybody ever seen Shania Twain?
No, I don't like probably have.
All right, maybe by the end of the period I'll show you a picture of Shania Twain. She's a country singer. She is absolutely gorgeous. Trust me on this. If I mentioned it to your dad will know. No question about it. All right, square the 2, that makes 4. 4 times 2 is?
Oh wait.
8. Minus, what's 7 times 4? 2. 14 plus 4, and negative 2 is the correct answer. Okay, any questions about that?
No.
Okay, good. So let's keep rocking here. All right, so listen. There's this thing called gravity. I don't know if you realize it or not. You're making it look. You don't like gravity. Any 2 objects on the face of the earth, you see this? These sunglasses and this pen have gravitational attraction between each other. They really do. You and your worst enemy, you are mutually attracted to each other. You are. You are. Gravity thinks it only like affects with the earth. It doesn't. Gravity is any 2 objects in the universe. You can put this pen here, and you can put a similar pen on Pluto, and there is a gravitational attraction between the 2 of them. Now, it's not strong enough to overcome the force of friction, so they're not going to move toward each other. The gravitational force to be computed is dependent upon the mass of the objects. Now, what's bigger, the globe or these sunglasses?
The sunglasses.
Are bigger than the globe. The one you're standing on, like the real globe. Okay. All right. Now, because the globe is so much bigger, it tries to get away. When I throw this rubber ball up, I'm giving it force. It's saying, let's get away from the globe. But the gravitational attraction of the globe, of the Earth, is so strong on this ball that as it tries to get away, it can't. And that attraction pulls it back to it. Kind of like love. Sometimes you try to break up with your significant other, and you're walking out the door, and then you see them and you're like, te amo, te amo. And love is in the air. Did you ever notice how the astronauts walked on the moon? Did you see them jump? Did you see how they almost fly, right? They get up, way higher than Earth, and then they come down. Well, that's gravitational force too, but the size of the moon is roughly 1/6 the size of the Earth. So on the moon, white men can jump. Okay? It is possible. So gravity does depend on the size of the objects being mutually attracted to each other. Did you ever hear how if like you're in a spaceship and you fly close to the sun, you would get sucked into the sun? Yeah, it's a very common understanding. And the reason is because as big as the Earth is, the sun is even way bigger. So the gravitational attraction of the sun is so strong that it pulls them in. And that, guys, is what keeps everything in orbit. So here is the sun, right here. Here's the sun, and here's just say Earth, third rock from the sun, okay? Now, this is the sun, and that's the Earth. Come on, isn't it obvious by looking at this diagram that that's the sun and that's Earth? Right, and that's what, Mercury and Venus or whatever?
Yeah.
Now, here's the thing. The Earth has two forces on it. One force says it wants to fly this way forever and ever, and one force is the gravitational force pulling it out. So as it wants to fly this way, the gravitational force pulling it back toward the sun makes it come in here, and what we create is the orbit that goes around the sun. And an orbit is the result of both the force of the object to go straight coupled with the force of gravity to pull it in. And if it wasn't for gravity, we wouldn't have a universe because everything would just fly away from the centers of the universe, like the sun or another sun, and the planets would not exist and you could not live. Okay, yes?
There's another sun.
Oh, every star is a sun.
Oh, okay.
But for our purposes, we are centrally around our sun. Now, within this, the gravitational constant, that force, in the English system is 32 feet per second squared, and in metric it's 9.8 feet per second squared. Okay? And the last thing you need to know is all such forces are represented with a quadratic equation. So if I write h of x equals negative 16 x squared plus 32x plus 100, and this was the equation of a ball hit by a professional baseball player, there's two things you need to know. This is the starting height that the ball was hit from, or thrown from. Maybe he's up on top of a building 100 feet tall, and he throws a ball, or hits a ball. And this is the upward velocity. So if I give you h of x equals negative 16x squared plus 75x plus 10, what's the upward velocity on this particular ball? 75. And what is the height from which the ball is hit or thrown? 10. That's all you need to understand for today. Ready? Write an equation of an object thrown with an upward velocity of 25 feet per second and from a height of 10 feet. Go ahead, do that. Write that equation out. It's going to look just like the one above it in blue, except you're going to change the numbers a little bit. Okay, h of x is equal to, now we're doing the English system, so we know it's going to be negative 16 x squared. And we know that because the a is always the first number. It goes in front of the x squared. What do I do after that? This is the typical beginning. What's the next step going to be? What? Talk, everybody, let's go.
Plus 25.
Plus 25
Plus 10.
x plus 10. Nice. Any question? Good, do the next one. One more try. Okay, what does it always begin with, everybody? Negative 16x squared. And when I say always, I mean in the English system. If I switch to metric, it would be negative 9.8. And then what goes next? Plus 20x plus 6. Very good. That's everything we needed to know. Any questions on that, guys? All right, so you are completely ready to rock and ready to roll in the beginnings of our studies of quadratics and parabolas, which is a very important part of our studies for the year. Another great C.S. Lewis book is The Great Divorce. Do you know that it's actually, I'm serious about this. It's actually the number 3 best-selling book of all time. Do you know what the number 1 best-selling book of all time is? The Bible, very good. What's the number 2 best-selling book of all time? Yes. What's the number 2 best-selling book of all time?
I know. No, caterpillar.
Nope, that's fourth. No, it's actually Euclid's Elements. It's about geometry. The number 3 is The Great Divorce by C.S. Lewis. Classic work. Classic, brilliant, super brilliant work. Have a great day, folks. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta.